Welcome to this video supplement on interesting absolute value problems, the first types that we looked at. So as we see on the screen, we are going to solve this absolute value problem. Perhaps you want to hit pause and try to start it off or work it through before we proceed. Now the first item we're going to do is set each of the insides of these absolute values equal to 0 to find our key numbers, what we called our key numbers. In this first set of absolute values, the key number is going to be that x is equal to 7/2. If you don't see that, come over here on the side and we set 7 minus 2x equal to 0. Solving for x, we divide both sides by 2, and x is 7/2. In this next set of absolute values, x is equal to -6 would make that equal 0. And what would make our final set of absolute values on the inside equal to 0 would be x is equal to a -2/5. So now what we do is we're going to make a number line. And on that number line, we're going to put those key numbers in sequential order. So -6 followed by -2/5 followed by 7/2. And that's going to partition our number line into 4 cases. Case 1, Case 2, Case 3, and Case 4. And then we're going to solve each of those cases separately. So let's start with what we're going to call Case 1. And for Case 1, x is going to be less than or equal to -6. And we can just put the equal sign option there for now. So as we go through and solve this, we're going to pretend that x is going to be some number less than -6 really when we plug this in. So for instance, let's go with x is equal to, let's say, -7. So if we thought about plugging in something like -7 right here, this is going to be positive. 7 plus some item is going to be positive. So we just take the absolute value signs off, and that would be 7 minus 2x. Then we're subtracting. If we put in a number less than -6, say -7, inside those absolute values is negative. To make it positive, we would have to put a negative sign in front of them when we take off the absolute values. So what we did right there was we said x plus 6 in the absolute value, in order to take those absolute value signs off, would have to develop a negative sign out front. And then if we plug in a value of x less than -6 over here, like -7, this would be -35 plus 2 is -33. That's going to be negative, so we have to put a minus sign out front of it or a negative sign out front of it in order to solve. So now what we're going to do is simplify and combine. The two negatives become really a positive. Over here we have to distribute our negative through inside the parentheses, so we get -5x minus 2. Combine your like terms. We have -x plus 13 is equal to a -5x minus 2. X is on one side, we'll add the 5x. We'll subtract the 13. So 4x is a -15 and x is a -15/4. Now if we're evaluating that, -15/4 is -3 1/4. You could use your calculator if you need to get a decimal. We need to compare that with back up here for the case. Is -15/4 less than or equal to -6? And the answer in this case is no. That would not be a solution because it does not check with the case value. So in this first case, we actually don't get any solutions. Let's go to our second case. So we'll call it case 2. In this situation, it's when x is greater than or equal to -6, but less than or equal to a -2/5. A nice value of x might be -1. Think about plugging in a -1. Over here on the far left is positive, so we just simply take off the absolute value symbols. Plug in a -1. This is also positive, so we just take off the absolute value symbols. But notice, when we do that, we have to leave the negative sign that was out front there. And then on the far right, plug in x equals -1. That is negative, so we will have to put a negative symbol out front to take off the absolute value signs. Again, we will distribute our negative through, and we will simplify accordingly. So we get negative 3x plus 1 is equal to a negative 5x minus 2. We'll bring the x's over to the left. We'll bring the numbers over to the right. And we shall divide by 2 to finish this off. We get x is equal to negative 3 halves. Again, we need to compare that with the case that we're considering. In this scenario, negative 3 halves does satisfy being larger than negative 6 and less than negative 2 fifths. So that one works. Let's turn our attention now to what we will call case 3. And that's going to be when negative 2 fifths is less than or equal to x, which is less than or equal to 7 halves. A nice number to plug in is x equals 0. First absolute value is positive, so we just take off the signs. Second absolute value is also positive, so we just take off the signs, but remember, we have to leave this negative sign out front. And then the final set of absolute values, inside of them is positive in that region, so we just take off the absolute values. Remember, the big idea is these things will only change sign around the key numbers. So as we do this, we distribute our negative here. We would get negative x minus 6. Combine our like terms, negative 3x plus 1 equals 5x plus 2. I'm going to get the x's on the right this time. That way they're positive. And I'm going to bring the number over to the left-hand side. Divide by 8 and we get x is negative 1/8. Now, compare with our case. Notice that, again, negative 1/8 would fall in this case. It does work. So in this case, pun intended, we would know that negative 1/8 is a correct solution. And we've got one more case. That will be case 4. And case 4 is going to be when x is greater than or equal to 7 halves. So pick like x equals 10. Over here, this is negative. X equals 10 makes the inside negative. To take the absolute values off, we have to change the sign. Hence, to remove those absolute values, we have to put a negative out front. Now for the second one, if we plug in x equals 10, that's positive, but don't forget we have to leave the symbol alone. So we just take off the absolute value signs without changing the symbol. And over here, if we plug in x equals 10, that's positive, so we can just remove the absolute value symbols when we're in this region. So now we distribute, we get negative 7 plus 2x minus x distributing, be careful to do that, minus 6 equals 5x plus 2. Combine our like terms, x minus 13 equals 5x plus 2. Get the x's on one side, I'll bring it on to the right. Get the numbers on the other side, and then we divide to finish it off. Ooh, I think we saw that solution earlier. But keep in mind we needed a value of x to be greater than or equal to 7 halves in this case. That doesn't happen. Negative 15 fourths is not greater than or equal to 7 halves, so this would not be a solution. So what's our overall answer to the question? Well, when considering this problem, we had no solution in the first area, we had no solution in the second area, in the fourth area. But if we go back in time, we saw in the second area it worked and we got negative 3 halves, and in the third area it worked and we got negative 1/8. So we had negative 3 halves, we had negative 1/8, and I guess it might even be better than writing an x to put just a no solution right there on each of those. So what is our final answer? Well, x equals negative 3 halves or x equals negative 1/8. Either of those items would work to satisfy our equation. The last item I want to re-emphasize in this tutorial, negative 6. The absolute value we just highlighted would be the one that changes sign around negative 6. Negative 2 fifths. The absolute value we just highlighted would be the one that changes sign around negative 2 fifths. And finally, when we consider positive 7 halves, that would be the absolute value of 7 minus 2x, that could change signs around 7 halves. So be mindful of which absolute values could change, whether they're positive or negative, around each of our key numbers. If we keep this in mind, Hopefully, solving some of these absolute value equations is not bad, but stay organized and follow the details along the way. Thank you for watching this supplement.